into the demo of the platform, the actual usage of the platform, and how we make things happen in a way that how we're trying to solve the problem that we're trying to solve. And in particular, I will start on a website, and specifically because I want to look at this section here. Now, why we do what we do? First of all, we as engineers, we always solve problems all the time. This is our job. That's what we getting paid for. But actually, not only as engineers. In engineering world, we're always talking about incidents, for example, right? Incidents is by definition a problem that we need to solve. It's something happened, we need to contain it fast, we need to find a solution, we need to find a solution that will actually hold water down the line in the future, right? So we enabling the fast containing with faster fixes and stronger fixes going forward. Now, the industry showed over the years that chronic problems appear, but chronic problems don't just appear on their own. They appear because we make them. And they're usually coming out from unsolved incidents. We patch the incidents, we're trying to find some very quick solution that will, contain the problem. And we're getting used to that. At the end of the day, after many months or sometimes years, that problem becomes chronic. And we just learn to live with it. So that's another thing that we want to actually address these chronic problems and get rid of them completely. Of course, when we're dealing with high cost, every company wants to reduce cost all the time. We're all trying to be profitable. When we're trying to reduce cost, we're making changes in the system, in the organization, anywhere that we touch, we're making changes. And that change within itself will create problems as well. So the system and the platform and the methodology allows us to make these changes in a more resilient way, faster, and actually, solve the problems before they become incidents and definitely before they become chronic. Same goes for low yield, right? When we're dealing with low yield, when we're trying to increase yield, I see low yield is kind of a chronic problem that we learn to live with it. So it's a problem that we need to solve going forward as engineers, especially when we're talking about manufacturing facilities, manufacturing companies, especially semiconductors, the ones that we mainly focus on. So every change where we're trying to improve yield, of course, again, brings problems into the table. We need to solve them. We need to solve them fast, efficient, and make the fix or solution resilient enough that it actually holds for the future. And of course, we always talk about the culture of innovation. Everybody talks about the culture of innovation. What innovation means? It actually, again, solving somebody else's problem, maybe internally, maybe externally for the client, but at the end of the day, it's solving somebody else's problem that somebody is willing to pay for. Even within the internal companies, somebody pays for that solution, right? So this is how we see and this is how we promote innovation. And that's the whole mindset of innovation. And we have to talk throughout the engineering organization or engineering community in the same language in order to enable that systematic innovation culture. So this is why we do what we do. And I will jump into the actual platform. This is the platform. And by the way, I want to go back a little bit. This website is not only marketing's website, there is a lot of material that we're publishing, as I mentioned, the webinars as well. So the entire history of webinars is recorded here. Everybody welcome to go back and watch what's there. There's courses that we provide as part of the many of them as part of onboarding, but we'll talk about that in a moment. Blog articles, it's basically a lot of them, it's a case studies. Case studies, this is the one that we just published today about a chronic problems that will be actually never solved. And there's a nice explanation about that. But this blog is not only information, it's actually teaching blog. And of course, the knowledge base, but we will touch on that during the demo. So let's dive in. First of all, That's the platform. Whoever didn't see that until today. The platform, that's a dashboard of a platform where we see basically everything that we have inside the workspace, and everything is organized in workspaces. You can think a workspace like an office where everything is closed within, nobody else except whoever has an access to that office cannot see what's going on inside. And we organize everything in projects, or we try to organize everything in projects. And project means it's any initiative that we work on to solve a particular problem. Again, going back to incidents, going back to chronic problems, and so on and so forth. Anything that we're trying to do at the end of the day is solving a problem. Now, in here, you will see projects and tools. Now, the tools are we allowing to use a individual tool without having a project if somebody needs to. But the better organization, especially when the project is long, is keep everything in within the bubble of a project. So let me dive into one of them. Uh, some people already seen that. We're using it a lot for a demo. And the reason for that, because first of all, it's a real thing from the past. We're allowed to share that. And it's probably one of the most complete examples out there. What I wanted to emphasize in here is we have a process or we proposing process. We're not enforcing, but it's a proposition of a process of every initiative of problem solving. And it always starts with an overview. An overview is usually something that comes from an email or sits somewhere in a document. Many times it's a one-liner saying we need to solve X and Y and so on, but there isn't a lot of information. And when there isn't enough information, people usually tend to, first of all, not focus on collecting that information. And that leads to a lack of understanding of the problem space and the system and so on. So we encouraging, or I'd rather say enforcing people to actually collect as much information as possible within this overview. But what this information is basically what we know about the system and the problem space before we start diving in and analyzing. And that's very important. Now, the system helps us to do that by providing an overview or what we call the completeness mark. Completeness is basically when a system goes in and reads that description and says, okay, it's 75% complete based on what we taught it to do, based on what we taught it to check. Uh, and it also provides some gaps and potential ways to improve that description going forward. For example, detailed impacts were missing in here. And while we work on improving that information, we can have it reevaluate the result and give us a better, potentially better or worse marking in terms of completion. This is very useful because, again, this information is important for us as human beings, but also the system is better equipped to provide us help going forward with the guidance throughout the project. Now, once we have completed that, and by the way, we can attach the files in that everything is protected with best practices. The team that working on this project is all here. Now, once we complete that general knowledge about the problem, we need to dive into problem statement. Now, problem statement is an interesting beast because, first of all, majority of engineers, at least the ones that I know, they don't like dealing with it. They just don't like building it because in their mind, they know what the problem is. The issue begins that when there is a team working on a particular problem or on a particular initiative, each and every one will have understanding of a problem, but the understanding differs. Basically, they all look at the same problem from a different perspective, and in their mind, they will have a different goal and different approach to the same problem solving. The problem statement is actually eliminates that difference between between different members of a team who works on it. Again, it goes back into we all need to talk in the same language, the same terminology, and actually have the same understanding of what we're working on. Of course, and this is where we have multiple guides. Of course, we're using AI, multiple guides that will give us hints about, what is the current situation is based on already known information. And this is why the overview is so important, not only for us, but also for the machine to help us with it. Now, what we always suggest, the machine, again, it's a guide. It's a pretty good guide, but we're the ones who solve the problem. We are the ones who eventually make the decisions. And even though it provides a nice description, we usually guide people to fight with it and argue with it. And that's very important to argue with it, right? Like any AI, even regular ChatGPT, the more you dig into that, the better result you get. It's the same concept here, right? The AI is basically a statistical machine and nothing more. We are the ones who make the decision. So in this case, we need to describe the current situation and disadvantages. Disadvantages are very, very important because that's defined why this current situation is bad, why we consider it as a problem, and so on. Of course, the ultimate goal, or what officially called the ideal final result, is where we actually want to get to if we had a magical wand. Where do we want to be? And we have to understand what prevents us from getting there. What prevents us from getting there? Again, there's many different AI assistants in here, and there potentially might be multiple things that prevents us from getting there. Again, these are hints, but mainly it's supposed to come from our own selves. Uh, Mechanically, we can basically select a few of them. And of course, once we have all of that information available, we can now construct the actual problem statement. In the problem statement, again, it's where we want to be against where we are today and the gaps that we need to address. And the gaps that we need to address is the actual problem that we need to solve. Now, once we have that and everybody is aligned, everybody is on the same page in terms of the problem that we need to solve, now we're diving into the heart of our system. And that's the creative thinking tools or creative thinking tools, or there's many names to that. We stopped on the creative thinking tools. Currently, we have 12 of them and building more as we go. I'll just go briefly on each and every one of them, what they do and their purpose. Generally, each and every one of these tools, they have their specific purpose in the workflow of problem solving. For example, inventive principles, it's 40 inventive principles. Officially, it's coming from a PRIZ methodology originally. This tool is built for to allow us to break contradictions. So any problem in the world pretty much comes from the fact that there is a contradiction somewhere. We do something, but something else gets worse, and so on. This tool is built to help us address these contradictions and compromises. Round robin ranking, it's a tool that allows us to make a reasonable comparison between multiple options and make a decision. Make a decision between, which option we want to go with going forward. Doesn't matter what the option is, whether it's an action that we're trying to make or I don't know, a reason of the problem that we're trying to address, and so on. Urgency importance, it's a part of a task management. Every project in the world will have tasks. And urgency importance helps us to prioritize these tasks, to understand which one we need to do now versus not do at all. 5 whys, that's probably one that most of you guys know what 5 whys is. We have our own twist to that. And 5 whys, we actually officially call it 5 plus whys because, again, I will show the example. I will dive into that in a moment. Action preventing action. It's a tool that we introduced quite a while ago. It helps us to identify customer needs through a series of questions. Brainstorming. We call it effective brainstorming because, again, we added our own variation to that brainstorm, to that traditional brainstorming. And the key here that we given the tools for people to understand what they can do with many, many, many different ideas that got generated throughout the session. And again, I will demo that. 9 windows. In simple words, it allows us to predict the future. We can talk about this later, but it's also coming from a PRIZ methodology. Again, pretty standard implementation here. Cause and effect chain. Very similar. It's also a tool that built for root cause analysis, but it's a more ramified tree. We will go into the demo of that. It allows us to, instead of digging deep, but it also allows us to look wider at the causes of a problem. Perception mapping, that's an interesting one. It's pretty popular as well, where it helps us to analyze blockers. So, for example, we have many different things that we're trying to do to achieve a particular target, but nothing changes. This tool will allow us to identify why nothing changes. What is the blocker? Functional modeling, I won't expand on that. I will dive into that in the demo, as well as process functional modeling. But overall, these tools are extremely powerful to allow us to understand either the system or the process level. And of course, the change flow thinking, last but not least. And this tool is allowing us to break down the dependencies of a change, understand the risks, understand what else needs to be changed, and actually, quote unquote, predict what else do we need to address when we create any change and by doing that, we reducing risk, understanding the scope of work, and understanding the cost, and so on. Now, the system also allows us to, it helps us to understand, okay, there's a lot of these tools. Which ones should we start with, right? There's a lot of tools there and more to come. Which ones should we start with? In this particular project, the suggestion is to start with root cause analysis or process function model. And there's a little explanation in here that basically describe what you're going to get from each and every one of these tools given this project. So let's dive in. First of all, cause and effect chain. Every tool is structured in kind of the same way. We kind of demanding to describe a subject of an analysis, or sometimes it's called systems, sometimes it's called a process. But at the end of the day, it's a subject of the analysis. What is it we're trying to analyze with this particular tool? The more details, the better, because this is where we, again, as human beings who work on this project, understand what are we trying to analyze with this tool, right? And everybody who's working on it is aligned. Then we're building the diagram, and typical diagram can look something like this, right? And where we're starting with the main defect that we're trying to analyze, where is it coming from, and potential causes. As you can see, again, as I mentioned, we going wider. In every branch, we can start digging deeper and deeper. Oops, excuse me. Digging deeper and deeper. Now, every one of these nodes, it holds, first of all, the description that you see here, but also some nodes. It's a convenience nodes. There is a color coding, again, for our convenience, whatever the team decides. For example, in our case, we decided that the red ones are the ones that we need to, do a deep dive and understand what's going on in there, or maybe do a deeper analysis in there. Now, we're building the diagram as simple as that. And in here, we also have some of the machine help. This machine, again, I will repeat that probably every time I show that the machine gives suggestions. It gives hints. We are the ones who make the decisions, and that's extremely important to understand. We are the ones who solve the problem at the end of the day. Uh, and this is where, yes, it's very useful to read what the machine suggests. And for example, we do decide to let's do incompatibility between new chemistry batch and existing process parameters. Okay, let's take that. And most importantly, for us as human beings, it's really hard sometimes, especially when there is a lot of information. It's really hard for us to look at the entire map and understand what's been already identified, what's not. The machine can do it very quickly. And this is where it's really helpful. It increases the speed of the analysis. Every tool that we're talking about, it increases the speed of the analysis. So that's just one of the examples. So I'll delete this node just to keep it in the same condition. Now, and the conclusion, of course, when we performing any analysis, the goal is to get some sort of results, some sort of conclusions. We're documenting that. Yeah, we're documenting that here, and we're encouraging to document it here because that is the outcome of these analyses. Anatoly, did I miss
Yeah,
anything?
yeah.
Mhm.
Please explain regarding idea documentations.
Right. So when we working on any tool whatsoever, including even problem statement, right? When we build a problem statement, when we're talking working on any tool, we can potentially generate an idea in the process. And that's the whole goal of the entire project, to generate the idea. And the idea is documented and can be documented from any place in the platform. Doesn't matter what we do and where we locate it. And that's very important because then we understand uh, inside the report that we will see where the idea came from as a result of what tool it came from. And that's important as a documentation of the thought process. So let's just drop it in here, some idea, regardless of what it is. Now, this idea will be collected in what's called Idea Manager, and we'll look into that in a second. In addition, in addition to ideas, every project will have tasks. That's also part of any project in the world. It's a collection of tasks. Check this parameter, go pull these results from the analysis, and so on and so forth. That's a collection of tasks for people to go and do and bring back for the next meeting. And speaking of meetings, meetings are also documented in here. Our next meeting. We're creating a meeting, and if we'll have time, I will dive into how the meeting's working as well. Now, we looked at the cause and effect chain diagram. Again, as you can see, ideas, tasks, meetings, all here. The next one in line that I wanted to show is the 5 whys analysis, or 5 plus whys analysis, how we call it. Now, why is it 5 plus whys? Of course, this one is actually 5 exactly, but the concept is we don't stop at 5, and we not necessarily have to get all the way to 5, but the key is to get to the fundamental cause of a problem. And what does it mean, fundamental? We like to use an example of health, right? For example, God forbid, I'm not healthy. I don't know, I have high blood sugar. And when you start to analyze why is that, at the end of the day, you might get to the fundamental issue that, maybe my mom wasn't willing to stop smoking when she was pregnant. Yes, it is fundamental, but it's not something that I can help it. It's not something I can change. So it's not it might help for a future generation, but for me, that's it. I'm done. But if we go into the higher level causes, which called auxiliary causes, I can potentially find a solution for me right now. It could be pills, it could be diet, it could be many different things. So all of these different solutions, they are auxiliary, they're solutions for auxiliary reasons or auxiliary causes. And that's the whole concept of the five whys. Again, same here, same thing here. We do get help from the machine with ideas. Yes, don't take them for granted. Fight with that all the time. Even when you sit in a room with somebody else and somebody else will say, "Hey, I think I know why." We're the ones who need to question that assumption all the time. There is no other way, right? So same here. Yeah, the machine will propose few options of the solution for that reason, and it's up to us what we do with it. So let's give it a second. Again, it does do a lot of work behind the scenes and digs through a lot of information. But here you go. You gave three different options that, how we can potentially solve that. Whether it's correct or not, that's a different question. And of course, if you remember what we talked about the making a decision, which one we take as a solution going forward, for example, we're allowing to rank the different solutions. I won't dive into the tool itself, but this is where the round robin ranking actually becomes very useful. And this tool is integrated in many different places where we need to make a decision between multiple choices. Okay, let's go next. The next one is effective brainstorming. Of course, why are we showing that? Because again, it's very popular. People do use it, people like it. First of all, because it's fast and easy, but it's fast, it has a perception of fast, not necessarily providing quick results. Same here, we encouraging to describe a subject of the analysis or subject of that brainstorming session, which is very important for people to understand what it is. And the brainstorming board can look something like this. Now, what you're looking at is a board of all the different ideas that got generated throughout the session in this particular project. But in general, everybody can come in and say, okay, again, some idea and document it here. But this, as you can see, a different color. It wasn't still designated to any area. And the designation is what's easy to implement, easy or not easy to implement, or easy or not easy to validate. So for example, if we drop it here, it will change the color, according to the area that it's in. Why is it important? These groupings, these groupings tell us that this is cheap to implement, cheap to validate the result. These ones, on the other hand, are very hard to implement and potentially very expensive. And it may take a lot of time to see the actual result of that implementation of idea, and so on. Now, let me delete that. Uh, Sorry, Anatoly, did I miss anything here?
Yeah,
Yes.
regarding the link.
Yeah. So now it's very convenient to have everybody in the room to actually work on the same board, but it's many times even more convenient to share a link to somewhere. Let me open that up. And that link is basically can be shared with anybody in the world. It depends on the settings that you decide to set in there. There is a description of that subject that we just put in place. What is it we're trying to analyze? And from here, we're collecting these ideas from people in the organization, from within the project, or from people around the world. This type of tool, this type of collection of information is implemented in multiple tools. Again, in route robin ranking, in perception mapping, in here in the effective brainstorming, and as well as urgency importance metrics. Any tool that requires us to collect potentially a lot of information from a crowd will have something like this implement. Uh, I think that is it for this particular tool. One last thing to show. Again, same option for comparing different results within a group. So we can't compare everything. We have to compare apples to apples and oranges to oranges. But this has allowed us to compare within a group. So for example, easy implementation, easy validation. Let's compare that. There's a couple of different ways. There's a full ranking and smart ranking. The smart ranking basically makes it faster. But still completes the same or even better results, to be honest, in especially when we're dealing with a lot of different options. All right, that was effective brainstorming. Let's go to the most interesting one in my mind, and that's the functional modeling. The functional modeling is probably one of our most uh, powerful tools that we have in our toolbox. This tool creates multiple things. First of all, it forces us to understand how the system works. And if some engineer says, I know how the system works, usually, no, they don't. Because they think that they know how their own little bubble works, but they don't know the entire system. They don't have the full grasp of the entire system. And that's very important when you're making changes, making decisions, and so on. And the typical model can look something like this, right? What we modeling here is, of course, the product of the system that we're looking at, that we're trying to analyze. And the product is what the system is built for, what the system is built to add value to, and so on. That's a very, very critical piece where we need to identify what is that product in the system. It also talks about models the entire system of components that related to that system that makes this thing happen. And components can be split in two different kinds. It's actually internal components of the system, just a regular component, or a supersystem. A supersystem that is something that that contributes or in any way, for better or for worse, for the functionality of a system, but it's technically outside of a system, or we, as human beings, as people who analyze it, decide we don't want to affect it, we don't want to touch it, it's outside of our control. So that's a super system. And of course, we have functions in between them. The function, that's basically the main difference between the typical modeling or diagramming that you would see out there versus the functional model. And function talks in a functional language, which means we looking at a particular component not as a component, but we looking at what function it actually provides and which other component it affects. And function means that we are changing a parameter of another component, and that's very important. Basically, because if we're not changing anything anywhere, then there is no function. There is no point of whatever, there is no potentially point of that component. So component exists to provide a function. There's four different kinds. There is a useful function. A useful function is basically a function that that particular component was built for, and it is performing in a way that it's supposed to, as designed. There's a harmful function. A harmful function is more of a, oops, I will put it back. A harmful function is something that a component was not built to do, but is still doing it. That's a typical contradiction. An engine is working, spinning, but it also heats the environment around it. The heating the environment is not a desirable function, but it's there. And of course, there's excessive, basically something that does whatever it needs to do, but does it too much, overheats. And same, insufficient is not enough, underheats, doesn't heat quick enough, and so on. Once we build that component, two things happen. first of all, we as engineers who model it, we understand how the system works in very small details. And we understand which component responsible and which functionality. But we also, once we have that model built, we automatically calculate a bunch of different things, like a functional ranking. And functional rank is something that is contributing to the value of the final product. In this case, the front-side chemistry is the biggest contributor, which means if we want to improve the system, we need to invest into that function, into that component, because it provides the most functions. And on the other hand, there's also a problematic rank. Problematic rank it's a number that will say this is a component, for example, air in this particular case, that contributes to the problems within the system. And in this case, it doesn't have any functionality at all. So if we want to simplify the system, solve problems within the system, make it cheaper, and so on, we need to focus on this component all the time. And we need to make sure that we can eliminate it, ideally. So potentially eliminate, there's a number of different recommendations that the system provides as well. And some of these which one was it? I believe, I don't remember which one was it. Yeah, for example, some of these components, some of these suggestions, they suggest to go to another tool, which is for the inventive principles, to try and solve a particular contradiction. So as you can see, many different tools, they start integrating together and work together. Now, another couple of different parameters in here is the operational effectiveness. It basically says how effective the system is given the current modeling. And perfectness. Perfectness is an interesting number because it talks about the ratio between the actual function that we need from the entire system relative to the complexity of the rest of the system. So the lower the number it is, it means the system is more too complex. We always want to increase this number of a basic function relative to the rest of the system. Now, that's not all. The functional model, as the system's always changing. We always trying to improve them. So we can basically model our future improvements going forward. So we can copy that, we can clone this particular model and start working on improvement or foreseeable changes as we see them going forward. And what that allows us to do, it allows us to see and understand how our system potentially going to look like and going to function and behave in the future after the change. And since it's a modeling exercise, we can see, okay, here's how it changed. So it was 19% here, for example, 17.4 here, and it became now 19. Okay, there is an improvement. Of course, it's not 100% perfect understanding of what actually is going to happen, but it's 90% of that understanding. We can model it. We can understand what the system will become after the change. And in here we have, for example, 4 different options for modeling and 4 different options for different variations of the changes of the system and how they're going to behave going forward. I'll pause here for a moment. Anatoly, anything
No,
to add?
I think it's okay. You can move. We have a couple of
Okay.
questions, but we will return to these questions.
Yeah, I will take the 5 minutes and
Mhm.
we'll
Okay.
leave the tail to the end.
Okay.
And of course, conclusion. Conclusion, it's typical. We analyzed, we came to some sort of conclusions. Let's document it. These different changes that we played inside the system, they also got documented as part of that exercise. Because again, it's important the progression of how we worked on a tool and what steps did we take going forward, and we will see that in the report. The last thing that I wanted to show is, again, this process of functional modeling is hard. It's supposed to be hard. There's nothing we can do. But at least we can make things a little bit easier to use the capability of AI in today's world. Capabilities of AI will allow us to build a model, a base model. So instead of us starting from zero, from a blank canvas, we can actually start with something that the machine already got the information from the description, got the information from the system description, got the information from different analysis, basically collected everything that related to this particular model inside related to this particular model inside the project, and it can build the modeling. It basically modeled the system for us to a particular level. And it takes about a minute, minute and a half. It takes time. Usually something like that will take hours or maybe days, sometimes weeks. It's a hard process. It's a difficult process, especially when different people in the organization involved. Nothing you can do about it. It's something that we have to do many times manually, but we can provide the basis with the machine. So again, let's give it a minute. We're comparing here a minute, minute and a half versus hours and hours and hours of work. Again, I'll pause here. We'll see on this spinning thing. It does take time today. Okay, so here's an example of a functional model that the machine basically extracted the wafer as a product, which is correct. It extracted different components based on its own understanding of a system and from a system description, from an overview, and so on, all the different components that it decided to make use of them inside the model. It mapped the functions. Now, again, is it the perfect model? Not necessarily. It's mostly incomplete, right? So this is where we as human beings now can start organizing better. And we're not starting from scratch. We're starting from some boilerplate work already done for us. And that's very important because that again shortens the time to value in terms of how we can get the results faster. This is how we get the results faster, and we're consistently improving this capability. Now, I have a couple of minutes more. I will dive into Ideas Manager. Idea Manager is, as I mentioned before, all the ideas they getting collected in this Idea Manager. And in this case, there's quite a few of them. There's that idea that I added. I will actually delete it. But these ideas are collection of our brain dump inside while working on the project. And the Idea Manager allows us to first of all, read everything in one list, compare them. It allows us to collect different uh, feedback from different people. Again, this is just an example, but this is where people can go in to say, in my mind, the gain is this from my perspective, but the cost can be 1 to 3 because there are some other dependencies. The risk is something else, and so on. This is a very important step, again, because we're collecting ideas from people involved in the project to understand, what is the potential gains or caveats inside each and every one of the ideas. Back to the ranking of all ideas, same round robin ranking is also connected here to, make us a little bit smarter in terms of choosing which one of the ideas will be taken further. And even mark, we decided this is our winning idea. So there's a lot of work to sorting and understanding the ideas once they got generated. It's not just a flat list. And of course, the final solution is the combination of these ideas. In this case, it was short-term and long-term solution. The context doesn't matter specifically, but this is where the final proposal for a solution comes in and getting documented. Now, why are we documenting that for the report? That's another thing that every engineer in the world just absolutely hates doing. I worked so hard, I invested so much time, so on and so forth. Now I need to generate the report as well. Come on, I don't want to do that. But this is something that we can do for them automatically on a click of a button. This report basically includes everything from a project background that we saw, the problem statement building, the winning ideas that we looked at, and of course the solution that we're proposing. But we're not stopping here. We have all the tools and the entire thought process documented in this one PDF document, where which tools got used, who used them, which idea got generated, who generated these ideas, and so on and so forth. If you think about it, it's a fingerprint of this problem-solving process. It will have everything under the sun. In this particular, here's the functional modeling that we just looked at, and so on. Now, yeah, the rest of ideas. So it's the entire documentation of our solution, not the final solution. Here's the problem, here's how we solve it, but it's actually a proof of why we solve it. And if somebody asks, how did you come up with this idea? How can you prove that this idea is actually the solution is actually holds merit? This is how. That's the proof. I will pause here and let's go to the questions. Let me open it up. Okay, first question. Okay, Anatoly's already answered some of them. Can you import video drawing from functional modeling page? No, not at this point. My experience with engineering having a different perspective. Okay. Right. So, David, you mentioned about revising again the problem statement. Absolutely. It happens all the time, and it's a normal workflow. Many times we've even seen where people started working on the problem statement. They they didn't even have enough knowledge, so they decided to go and use one of the tools, for example, functional modeling. And that tool helped them to define the problem in the first place. So yes, absolutely. And that's why I mentioned that yes, we have the process, but we're not enforcing it. That is the exact reason because it's normal to have a back and forth many times throughout this process. Um, David, you also asked the pages Alex uses can replace a whiteboard. Yes, whiteboard. We're trying to replace not only a whiteboard, we're trying to replace notebooks, we're trying to replace emails. Emails is a terrible tool for documentation. There is nothing you can find in there. We're trying to replace, shared space for documents because when you have, you know, 10, 20, 30 documents, it's fine. When you have few hundreds, good luck. You're not going to find anything in there, especially if it's Google Drive uh, or what's the Microsoft one? I don't remember. Uh,
Teams.
it's very so we're trying to replace all of these different bits and pieces of information that sits everywhere under a project that related to that particular initiative and not related to the original documentation that's related to meeting notes, that's related to the tasks that have been executed, everything that related to the project, we're collecting inside the project. And that's the whole point of it. Does it provide trimming recommendations? Not yet, as Anatoly mentioned. But the trimming, one of the functionality of Trimming is basically, you know, you make a copy of it and start trimming, start understanding your world going forward. So, Frederick, from that perspective, we don't yet specifically provide a recommendation for trimming, but the tools allow you to do it yourself today. Can you import Visio drawing into the functional modeling page? So this is interesting. In general, you cannot take a Visio or any other tool drawing into here, but you can take a screenshot of that Visio drawing, put it in the description, and press a button of AI. It will most likely do the right job. That's an interesting one to test, by the way. Um, Functional modeling, there is no interaction matrix. Uh, Frederick, can you clarify that question?
Yes. When I do function modeling, usually I do the interaction matrix first to make sure I don't forget any interaction. So it's a matrix, you
Okay.
have the components and you put a plus if they touch, and then you need
Hmm.
a function between the two. If I do it directly from the chart, as you do here, I might miss
Hmm.
an interaction. There is a risk.
Right,
Yeah.
right. So we currently don't have something like that, but we are working on something called a validation functionality. And validation functionality is basically something that will also probably sit here or somewhere in the interface, where it will say, listen, you have a component that missing functionality. Either why is it there? Maybe it's not supposed to be, or you actually missed a real functionality. So we coming to that problem to solve that problem from a different direction a little bit. Instead of specific matrix, we're saying in a more human language, because we have the capability of AI today, in a more human language saying, listen, it's all good, but here's some missing pieces. So we're going to approach it from a slightly different angle. I realize that I'm not aware of what the actually happening here,
Have
but
a
the
look
solution.
on message from Jack at
Yeah,
the very beginning.
I'm oh, very beginning. Sorry, my experience with engineering having different perspective and fit to some degree of social and problem solving is measurable. Uh, Jack, do you mind clarifying what you mean by the first
Well,
message?
I'm just looking at the. I'm not sure what the final solution was, but it looked like it was a showering wash instead of a single stream.
In this particular case, yes.
I mean, I look at that solution and that looks like a simple application of separation in space.
Could be.
Seems to me there's a lot simpler way of getting to that answer than going through this entire software process. That's my gut reaction. Again, I don't have all the background, but
Right. So my answer to that, I believe that, some people already versed in their mindset think in a particular way, in very particular way. So, for example, either you've been trained in a particular way as an engineer in the past. So you've been trained to think about problems in a particular way, in a particular structure. Unfortunately, and that's the whole reason why we do what we do, is majority of people today, majority of engineers do not think this way at all. They go into the room and they start brainstorming and firing idea into the air. That's what actually happened in the industry today. And yes, I agree with you. Some people, some individuals out there, they don't need to get through this software process specifically, but they will build that process in their head, whether you want it or not. Uh, we're trying to systematize that process. Does
By
it
the
answer?
way, in this particular case, what we learned that the chemistry just evaporates from the wafer. And if it evaporates, defect remains on the wafer. This is the point. So we should not to remove defects. We should think how to keep solution on the wafer. By the way, we have hub. Some projects are published, and you can in our website to get to the hub and have a look on projects. Of course, people don't like to publish their projects. Therefore, it's mainly my projects or projects by my students. I teach students in university. I created course engineering thinking. We, we teach students physics, chemistry, mathematics. We don't teach them how to think. This is what I'm trying to do. And there are some excellent projects by students.
Thank you. That'd be some good stuff to look at later. I guess my point is that my experience is that the vast majority of times that many problems are solvable with the simplest of trees tools like IFR and resources and separation principles, and going into this level of detail just tends to overwhelm people. Just a comment based on my experience of 15, 20 years.
Yeah,
This is excellent
100%.
example, I see. The typical situation when people sit in the conference room, drink coffee, check the telephones, and they said, this is brainstorming. I always say it's brain guessing. What are you doing? Stop brain guessing, because to say
Agreed.
check the temperature, it means it's the same like to say 5 red. This is the same. Please analyze, please learn, and make a decision. By the way, we have very good onboarding process. We have lectures for onboarding, and please don't hesitate to contact us, and we will help.
I understand. I've been teaching TRIZ for the Mechanical Engineering Society in the States here for 10, 15 years. So I'm just bringing my experience to the discussion. That's all.
Oh, 100%. And I think you just said something extremely important. You're teaching that, you're aware of the methodology. Your thinking process is completely different. Same as any trees practitioner out there, or most of them, or at least some of them, will have a different way of thinking. 100%, right? What we're trying to do with these tools and the entire platform is, first of all, give less emphasis on the actual trees itself and create more practical tools that can be used technically by anyone. Yes, you need some level of learning to make these tools useful, 100%. And that's why we provide these courses. But the goal is to democratize these tools as much as possible. So it's not available just a few selected ones, but available to anybody, eventually contributing to the rest of the world, hopefully.
Okay, this is David. Can you
Thank
hear
you.
me?
Yeah.
Can
Hey,
you hear
David.
me?
Yes.
You'll see my comment down there about a fractal design when you showed the shower head. I don't know if you've ever been introduced to or aware of a fractal flow distributor. And what it does is can you go to the shower head one? Okay. Where you have all the little streams of water coming down, the flows in those are going to be different because of where they are in the piece of metal. The fractal design changes that where all the flows from each stream are the same. So if you in your wafer cleaning example want to get a flow that is uniform across the wafer, you could use a fractal. That's my whole point. I used fractals a few years ago in a project very well, And wherever I see chances to introduce other people to it, I like to do that. That's all.
Right. Yeah. And that's a perfect example where somebody comes up with an additional idea throughout the project as well. And yeah, great. Amazing. And I think this is the actual result, final result of the implementation.
By the way, what we did, we just increased pressure in the chamber, just in order to reduce the evaporation rate. That's all. Very easy. And again, we have a number of very good examples in the hub.
All right. We'll stop the recording.